Why Earth is falling toward the sun, but never crashes. Every second of your life, Earth is falling. Not straight down toward the ground, but sideways through space.
Right now, our planet is being pulled by an invisible force so powerful that it controls the motion of entire worlds. That force is the gravity of the sun. And if gravity is pulling Earth toward the sun every moment, then one question becomes almost terrifying.
Why don't we crash into it? Why doesn't Earth spiral inward? Why doesn't Mercury plunge into the flames? Why doesn't the entire solar system collapse into the giant star at its center? The answer is one of the most beautiful ideas in all of science. The planets are not simply floating around the sun. They are falling around it. And this cosmic fall has continued for billions of years. Welcome to Infinite Science. Look at the solar system from far away, and it seems peaceful. The sun glows at the center. The planets move in graceful paths. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune all travel around the sun in a steady cosmic rhythm. But this calm picture hides something much more intense. Nothing in the solar system is truly sitting still. Earth is racing around the sun at about 67,000 miles per hour. Mercury is moving even faster. Jupiter, the largest planet, is carrying more than 1,000 Earths worth of mass around the sun. Neptune is so far away that one full trip around the sun takes about 165 Earth years. The solar system is not a quiet clock. It is a high-speed gravitational machine. And the only reason it works is because of balance. A balance between the sun's gravity and the planet's motion. To understand this, imagine holding a ball in your hand. If you let go, it falls straight down. That is gravity pulling it toward Earth. Now imagine throwing the ball forward.
It still falls, but it also moves sideways. The faster you throw it, the farther it travels before hitting the ground. Now imagine throwing it so fast that as it falls, the ground curves away beneath it. The ball keeps falling, but it never reaches the surface.
That is what an orbit is. An orbit is not the absence of falling. An orbit is continuous falling. Earth is falling toward the sun, but it is also moving forward so fast that it keeps missing the sun. Again and again and again. That is why Earth does not crash. It is always being pulled inward by gravity. But its sideways motion carries it around the sun.
Gravity pulls inward. Motion carries forward. Together, they create a curved path.
The sun is not just a bright object in the sky. It is the gravitational ruler of the solar system. It contains more than 99% of all the mass in the solar system. That means almost everything nearby is controlled by its gravity. The planets, asteroids, comets, dust, even distant icy objects billions of miles away. They are all responding to the sun's pull. But the sun's gravity does not simply drag things straight into it.
The way an object moves depends on both gravity and velocity. If a planet had no sideways motion, it would fall straight into the sun. But planets were born from a spinning disk of gas and dust. When the solar system formed about 4.6 billion years ago, material swirled around the young sun. As that material clumped together, it formed planets. Those planets inherited motion from the original spinning disk. So from the very beginning, The planets were already moving sideways. The sun pulled them inward. Their motion carried them forward, and stable orbits were born. But planets do not move in perfect circles. That is another common misunderstanding. Most planetary orbits are slightly stretched circles, called ellipses. An ellipse is like a circle that has been gently pulled from two sides. The Sun is not exactly at the center of these paths. It sits slightly off-center, at a point called a focus. This means that each planet is sometimes closer to the Sun and sometimes farther away. When a planet gets closer to the Sun, it moves faster. When it gets farther away, it moves slower. This is one of the great laws discovered by Johannes Kepler. The planets sweep around the Sun in a pattern that is not random, not chaotic, but mathematically precise. Mercury has one of the most stretched orbits among the major planets. Sometimes it is much closer to the Sun. Sometimes it is farther away. And because it is so close to the Sun overall, it moves incredibly fast. Mercury completes one orbit in only 88 Earth days. Earth takes 365 days. Mars takes about 687 days. Jupiter takes almost 12 Earth years. And Neptune takes about 165 Earth years. The farther a planet is from the Sun, the longer its orbit takes. Not just because the path is larger, but because the Sun's gravity is weaker at greater distances. Think of the solar system like a giant racetrack. Mercury is on the innermost lane. Its track is short, and the Sun's gravity pulls on it strongly, so it speeds around quickly. Earth is farther out, moving more slowly. Jupiter is much farther, moving slower still. Neptune is so distant that its path is enormous. Since Neptune was discovered in 1846, it has completed only one full orbit around the Sun. That means a single year on Neptune lasts longer than many human lifetimes. The planets all follow the same basic rule. The closer they are to the Sun, the faster they move. The farther they are, the slower they move. But every planet is still part of the same gravitational dance. Now comes the dangerous question. What would happen if Earth suddenly slowed down? The answer is simple and terrifying. If Earth lost enough of its sideways speed, the Sun's gravity would begin pulling it inward. Earth's orbit would shrink. The planet would spiral closer. Temperatures would rise. Oceans would boil. The surface would become uninhabitable. Eventually, Earth could fall into the Sun. But if Earth suddenly sped up too much, the opposite could happen. It could escape the Sun's gravity. Earth would drift away into deep space. The Sun would become smaller and dimmer. The planet would freeze. The oceans would turn to ice. Earth would become a dark, wandering world. So our survival depends on motion. Not too slow, not too fast. Just balanced enough to keep falling around the Sun. This balance is not only happening with Earth, it is happening everywhere. The Moon is falling around Earth. Earth is falling around the Sun. The Sun itself is moving around the center of the Milky Way galaxy, and the Milky Way is moving through the universe. Nothing is still. Everything is in motion. The solar system may look like a flat diagram in textbooks, but in reality, it is moving through space like a spinning, drifting, living structure. The Sun is not sitting motionless while the planets circle around it. The Sun is traveling around the galaxy at hundreds of thousands of miles per hour. The planets are orbiting the Sun while the entire system moves through the Milky Way. So the true path of Earth is not a simple circle, it is a spiraling journey through space. Every year, Earth returns to a similar position around the Sun, but the Sun itself has moved. The entire solar system has moved. We are never truly in the same place twice.
Gravity is what keeps this whole system together. But gravity is not a rope. It is not a physical chain. It is the bending of space and time. Albert Einstein changed the way scientists understood gravity.
Before Einstein, gravity was often described as a force pulling objects together. That explanation works very well for many situations. But Einstein showed something deeper. Massive objects like the sun curve the fabric of space-time around them. Planets follow those curves. Imagine placing a heavy ball on a stretched rubber sheet. The sheet bends. Now roll a smaller ball nearby. It curves around the heavy ball because the surface beneath it is warped. That is not a perfect model, but it gives the basic idea. The sun bends space-time. Earth follows the curve. From Earth's perspective, it feels like we are traveling forward, but space itself is curved around the sun. That curved path is the orbit. So Earth is not being dragged by a visible force. It is moving through curved space-time shaped by the sun. But if gravity controls the planets, why don't their orbits eventually stop? On Earth, moving objects slow down because of friction. A rolling ball eventually stops. A car needs fuel to keep moving. A thrown object falls to the ground. But space is different. Space is almost empty. There is no thick air pushing against the planets. There is no giant surface creating friction. So once a planet is moving, it can keep moving for an extremely long time. Earth does not need engines to continue orbiting. It does not burn fuel to move around the sun. It keeps going because there is very little resistance in space. Its motion was inherited from the birth of the solar system, and for billions of years, that motion has continued. Still, the solar system is not perfectly unchanging. The planets pull on each other too. Jupiter's gravity affects asteroids. Venus and Jupiter slightly influence Earth's orbit. The moon affects Earth's tides and rotation. Tiny gravitational interactions are happening constantly. But the system is stable enough that Earth's orbit remains safe over human timescales. The balance is not fragile in the way a glass is fragile. It is more like a giant rhythm. A rhythm shaped by gravity, distance, speed, and time. The planets are locked into paths that can last billions of years, but over extremely long periods, orbits can change. Stars passing nearby, planetary interactions, and the life cycle of the sun can alter the future. One day, the solar system will not look the same. The sun will age. It will expand into a red giant. The inner planets may be scorched or swallowed. Earth's future will be transformed. But for now, our planet remains in its ancient orbit, falling, moving, missing the sun, surviving because of motion. There is something almost impossible to imagine about this. You are sitting on Earth right now, maybe in a room, maybe holding a phone, maybe standing outside under the sky. It feels still, solid, quiet. But that feeling is an illusion. You are on a spinning planet. That planet is racing around a star. That star is traveling through a galaxy. That galaxy is moving through the universe. At every moment, you are part of a motion so large that the human mind can barely hold it. And yet, because everything moves together, we do not feel it. The ground seems still because we are moving with it. The atmosphere moves with Earth. The oceans move with Earth. The mountains, cities, forests, and people all move together. The entire planet is falling through space as one world. So how do the planets revolve around the sun?
They do it because gravity and motion work together. The sun's gravity pulls them inward. Their forward speed keeps them from falling straight in.
The result is an orbit, a continuous fall around the sun. Mercury races close to the fire. Earth follows at just the right distance for life. Mars moves through the cold desert beyond us.
Jupiter dominates the outer solar system with its massive gravity. Saturn carries its rings through space. Uranus rolls around the sun, tilted on its side. Neptune drifts in the deep blue darkness, taking 165 years to complete one orbit.
Each world has its own path. Each world has its own speed, but all of them are tied to the same star. The sun is the anchor. Gravity is the guide. Motion is the escape from collision, and orbit is the balance between the two.
The next time you see the sun, remember this. Earth is not simply sitting beneath it. Earth is moving around it at incredible speed, and every second, the sun is pulling us inward.
But we do not fall into the flames. We keep missing. We keep curving. We keep orbiting. That is the hidden miracle of our solar system. The planets are not floating randomly. They are not held by invisible strings. They are worlds in motion, trapped in a cosmic balance that has lasted since the birth of the solar system. Earth is falling toward the sun, but because it is moving sideways fast enough, it never crashes. And that is why the planets revolve. If you enjoyed this journey through the hidden motion of our solar system, make sure to stay with Infinite Science, where the universe becomes clearer, deeper, and more extraordinary with every question.
Because the next time someone says Earth simply goes around the sun, you'll know the truth. Earth is falling through space, and every day we survive because we keep missing the sun.